Okay, more testing. I'm still have 61 volts going into the rotovertor and pulling from the grid. And I have that one UF cap across here, and to tune it, occasionally I'll put another one to make it 2 UF across the primary. For example, right now, how it is now, with 1 UF it reads 58 milliamps input. I hook this up and it goes all the way down to 39. So a 2 UF, how it is now, is better. But let's leave it at 1 UF, because here's where the action is over here. I have another transformer. This is 6.7 ohms on this side, 0.6 on this side. I have it written somewhere. Here it is. 0.6. 6.7 ohms here. 0.6 over here. Now what I've done is I've hooked this in series to the run cap. It comes off line 3. It goes in one side, comes out the other. Goes in one side of the transformer, comes out the other side of the same primary. And it goes to one side of the cap, the run cap, 4 UF. And that goes to line 2, which shares with the input. So it's a transformer in series. I guess you'd call this vectoring. Now, what happens when I short out this other side of the transformer? Okay, right now I have 58 milliamps. I'm going to short it out. Short it out. It went down to 49, and what happens when I add the 1 UF? No, it doesn't. So you don't want 2 UF here. You want just 1. Okay, so how much current over here on the 0.6 side of it is there flowing through here when I short it out? Okay, that's 1.5 amps of current in AC shooting through that side. And look, it's gone down to 45 milliamps draw. And you know, oh hey, let's try the 1 UF now again. I'm adding 1 UF. No, doesn't help. Okay. Now, what do we got in voltage coming out of here? Isn't that interesting when you don't short it out and it's open, it draws more current. Not that interesting, but it's interesting. So now let's see what the volts is. I have volts in AC now. It's only about 4 volts. There's the volt, 3.9. So, what I like is that good current. And it doesn't affect the draw. Not very much. Let's short it out again. Short it out. Draw goes to 49 or 50. Again, I want to try this again. Nope, it doesn't help. Okay. This is with a 4 UF run cap. Let's try a 3 UF run cap. Remember, we're doing this with 61 volts coming in, not 110. Here's a 3 UF cap. Now what do we got? Yeah, we dropped the input down some more. Let's again see what's happened. That doesn't help again. When I had some really big caps over here, that was making a difference, adding one more UF to the capacitor over the primary. But it's not doing any good now. Okay, so we got 3 UF here. Let's see. Again, I have it shorted out. Take the short off. It goes all the way up to 57. From, with shorted condition, 37. See, so there's some potential here, you know? When you start making current. Now, I'm gonna, I call it crowbarring. We're gonna put the ammeter that is in AC amps. We're gonna put it right across there instead of a direct short with that yellow wire. Okay, it's shorted out. The ammeter reads, uh-oh. What happened? Did I blow a fuse? One moment. Yeah, I fixed it. For the 3 UF run cap, not a 4, which I just did, 3 UF gives you 0.91 amps, almost an amp in AC coming out. Not bad. And look at how much the draw has gone down while shorted. Now if it's not shorted on the secondary side, not shorted, goes all the way up to 57. Shorted on the side, and it drops down to 35. So, let's see what the voltage is over here. The voltage is 4 volts, 4.1. Now it'd be nice if the voltage here was 15 volts. And I could probably make my own transformer that would have like 3 times more winds on the secondary side, and then have about 6 ohms on this side, something like that. Have the ratio good. Alright, so what have I tried? I tried boosting that 4 volts up with a booster, and it didn't work. I tried 2 different boosters, that didn't work. I tried another transformer that's 120 and 12 on one side, and I increased the voltage that way. It got up to about 67 volts, but now it didn't have any amps like you see now. So I'm getting somewhere with that. And I also tried vectoring this out, in that you put a capacitor across it. This is, I'm working with the secondary of this transformer now. It's like a 12.5. And now now run another transformer side in series. So we got this coming out here, green wire goes in, comes out here, and then I hook this yellow wire up over here. There we go. Now I have vectored, I guess I have, this secondary side as it goes out here through one side of this and into this cap, and the other side of the cap connects to the other side here. So essentially you put a cap parallel to here, but then you add a transformer in series to one side of the cap. I guess that is vectoring. So what do we got now? What happens when I short out this side? Nothing. Let's see what the voltage is on this side. Now, when I did this before, I just didn't have any amps anymore. It like sucked away all the amps. But let's see, maybe I got lucky here. We're just working with AC now. Yeah, no voltage. So what I should do is reverse this transformer. And it's exciting. Okay, now I'm going to go through the other side of the transformer that's in series now. And now I'll hook up the voltmeter to see what's coming out of here. I'm sure there's nothing. Actually, I'll probably have some good volts. Just a minute. Okay, what I did was now I have 12.4 volts coming out of this transformer. And what I did is I used to have a 12.5 and I went all the way up to 35. And now let's go back to 12.5 on this, let's call it a vector cap. See, the 12.5 only gives you 3 volts, but you use a big cap over here, a 35, and it goes up to 12. So now I got some battery charging voltage. And so again, this cap is essentially in parallel across the secondary, but there is a transformer half in series to it, one side of the cap. Okay, but now you would go, oh great, we have good voltage. But now let's check what the amps is. And this is where it's going to fail, I think, because I did this before, but maybe I'll get lucky. Okay. Here's the output of that transformer. It's secondary now. The primary is in series to this transformer output going to this cap. So when I touch this over here, it'll tell you what the amps is. There, it shorted out the voltage to nothing, as it should. And we show almost 0 amps. I'll put it in milliamps here. Just like 6 milliamps. So, well, maybe I should put another big cap over here. Let's put a 30. I'm running out of jumper cables. I don't think this is going to help. Okay. Now for voltage, we have okay, here's the output of this, the secondary of this transformer, the second one. It goes to across here, and this will tell you the voltage. Nothing, not much good voltage. This big cap kind of killed it. Anyways, I'm going to call it good for now. So you see, I did pretty good today, actually. Seems like I need to wind a special transformer just for this purpose. Okay, thanks for watching.